Hello and welcome back. My name is Gustav Beka Sayudha with student ID number 13012133223. And here we're gonna do the coding for our previous video, which is the pseudocode of the problem of week 2 programming algorithm. And we're gonna do the coding with the, I'm sure you already see here. We're gonna be using Go. And it's still the same problem. We're just gonna translating it into a program, an actual working program. You can pause the video, watch, read the problem carefully, and we're just gonna jump straight into the coding. I'm just gonna explain a little bit here. Based on our pseudocode, right? Based on our pseudocode, we're gonna need three three variables that we need to declare, and we'll declare them here: integer and float, and we're asking for an input for the user for the integer that we're going to use in our formula here. And it's a lot of to unpack to read this. It's quite long. It's not the same as the one in the problem, but I can assure you it is the same. And we're just gonna run the code. And yeah, first thing first, we need to go with the problem one. Go. Right? I mean, it's already done here. When you haven't compiled it, this exe program, exe file does not exist. And after you compile it, then it exists. Now we're just gonna run the program. We're just gonna use program one exe. And here you can see it's asking for an input. Let's do 2 and 2. It's the same as the test case here for 2 and 2. The output here for 274545, and let's see whether it's true or not. And it seems to be true. Seems to be the same. So yeah, I think problem one is pretty simple. Just put the numbers into the formula, and the output should be the same. And we just come straight to go to the next problem, problem number 2. And here it's basically a review. You can read about it more if you pause the video here. And we're just gonna jump into the coding. Pretty similar. It's pretty simple and similar to our pseudocode here. Yeah, you just need to translate that into an actual code using this Go syntax. First, we limit the year variable for the year that we're gonna input, and the rest is gonna be the result. And we're asking for putting a comma there. Please input the year, and here we're gonna input the year on line 10, and we calculate the result here. If the year is divisible by 400, or if the year divisible by 4, or and the year is not divisible by 100, and it's gonna determine whether it is a leap year or not. And if this, we're gonna see if this could really work, right? We're gonna just do this problem 2, right? Problem 2, enter. Yeah, no problem there. And we're just gonna change here. We're using problem 1 here. It's easier than having to routine into the okay. What year is this? Year is 2022. Yeah, it still doesn't feel like it's already 2022 for me. It still felt like 2020. I felt like the time stopped at 2020 and the virus hit, the pandemic hit. And code works here. You want to test another year? No problem. How about 4040? And of course course it's a leap year because it's divisible by 4. And that's pretty simple for problem number 2, and we're just gonna go to problem number 3. Here we have problem number 3. Basically, it's a store promotion. If you buy above, if you have any purchases above a certain threshold, you get a discount, and at another certain threshold, you get the cashback. You can read more about it if you pause the video. To read about the question here, the problem. But with just one string, gonna go straight into the code column. It's pretty simple. First, we declare the variables that we're gonna use. Set the total. The total is gonna be the amount of money paid. Card, whether you're card or not. Discount, whether you're eligible for a discount, and cashback, whether you're eligible for a cashback. First, we're gonna ask for any input. How about this time we're gonna do it different. We're just gonna first compile this, right? So the compile, as you can see here. If you haven't compiled, it's only gonna this executables doesn't exist, as you will find. We're gonna do it different here. We're gonna explain and write the program. I mean, run the program. Where we are right now is it's asking for the total amount of purchases and whether we have card or not. And let's say how I like exactly 200,000, but I don't have card, so let's put false here, right? Because card is brilliant. Do I get a discount? Do I get cashback? Let's see. Apparently, since you don't have the membership card, you are eligible for a discount, but not the cashback. That's basically it. This one is pretty easy to understand here, I think. So let's go to the next one. Problem 4, it's quite easy, right? Once again, you can pause the video and read more about the problem. But the problem is basically you put a number, and you put a positive integer from 0 until 999, and you need to separate these into hundreds, tens, and ones of said number and bring the results to the user. We're gonna do the same one as before. And problem 5. This is asking for an input. So we're already declared the variable that we're going to use. So we're at the point of scan or asking for any. How about 666 as a fun number, right? So let's add that. And if display the correct result, it separated the hundreds, the tens, and the ones. But since it's the same number, you can't really see that. So let's do like 3 different numbers. 253. Let's separate the 200, the 50, and the 3. And how does it do that? Okay, let's go to the coding. The 100 is integer division. You divide the x by 100 and you change it into an integer. So basically, the number after the comma is gone. Right? If you try to divide this by 100, it's going to go 2,53, and the 53 is going to be gone, and you only gain the 2, and that's going to be stored within hundreds. And rest. This is not a result, rather rest as the remains of the division. And the remains of the division, that's right, that's modulo. Modulo of 100, we're gonna store it in rest and make a similar for variable tens and ones as well. You can read more about this, right? And yeah, I think problem solved, and we're just gonna go to the next problem. And problem number 5. Now this is a little bit, well, not really. This is gonna be a lot more complex than the previous ones. And once again, you can pause the video here. I'll read more about the problem. Basically, it's a straight plus program. It's checking whether you have a straight or a plus in your 5 cards. If you input 5 cards, then it's gonna determine whether you have a straight or a plus. Now, based on the problem, the number of the cards that you're gonna be putting in is gonna be in order of the number of the cards. So I put this here in order of the number. Basically, this is the variable declaration, and you might say, oh, that's a lot of variables. Yes, it is a lot. Because I'm using individuals, and there might be another optimal way to do this. I'm sure there is, like using an array or something. But for now, we're gonna stick to the basics and just use the simple variable and if else. And we're gonna go into the algorithm part of the code here. The coding pattern. First one is gonna output a prompt asking for the input of the 5 number, and then let's do this. The second 5 cards in order of the number. Let's see, I have 1 clubs, 2 clubs, 3 clubs, 4 clubs, and 5 clubs. This should be straight plus. This is gonna be a lot on that. But let's see if the code works. It does not work. Okay. Okay, yes. Okay, yeah. No, there's no problem at all with problem number 5. Everything is good. So yeah, let me explain it again. Complete problem 5. Yeah, and problem 5.exe. Now it's asking for 5 times, right? 1C, 2C, 3C, 4C, 5C. It should be straight plus here. Yeah, okay. No, I'm not a bit scared about my wrong code or anything. So yeah, there's quite a lot here. So yeah, it's asking for input for each card, which is string, right? And then we're gonna see whether, okay, we're gonna see this. Let's see, diamond, 11 diamond, 12 diamond, and 13 hearts. It should be straight but not flush. Yeah, that's straight. Okay. Yeah, because the input are string, right? We need to separate those, and we need to separate everything else. We need basically to separate the numbers and the card suit, and we're checking from that whether the length of the string is 3 or more or less, right? If it's more, then it's gonna simple answer. It's gonna take the index of the second character, right? For example, this is a 3 long, right? It's gonna take the index is the number of the second character here, plus 10, right? This is 13, 3 plus 10. If it's not, then it's gonna take the first number, like 9C here, it's only just gonna take the 9. And it's the same for all the cards and numbers. It's card 3 to number 3 and so on until 5. And the suit is simpler because since suit is string, card is string, it's really easy to operate on string. And here we have it's basically just gonna take the last character of the string, card 1. Use the string card 1, string card 1, and it's gonna check the length, and it's gonna pick. See, this is the index of the last character of the string. So now let's explain it here. Right? Here we have 13 hearts, right? 13 each. It's gonna check the length, and then the length is 3. Then it's gonna pick the index of the last character and put it into the suit corresponding to the card. Right? Here it is card number 5 and suit 5. And for the straight and flash, straight is basically simple, just like number 2 is equal to number 1 plus 1. So in order like 1, 2, 3, 4, 5. So yeah, number 3 is equal to number 2 plus 1. Is it? Number 3, number 2 is equal to number 2 plus 1, and so on and so on. And the suit is much simpler. The flash is much simpler. The suit 1 has to be the same as suit 2, and suit 2, suit 3, suit 4, suit 4. Basically, in the pseudocode, like the simpler form of it, like this. Suit 1 must be the same as suit 2, must be the same as suit 3, must be the same as suit 4, must be the same as suit 5. And therefore, it's going to be a flash. And yeah, that's basically it. We definitely didn't run into any problem in problem number 5. So yeah, thank you for watching and stay healthy and have a nice day.